Welcome back guys to the second video of our chapter 1 rates and return of CFA Level 1, book 1, that is Quantitative Methods. So in the previous video we have talked about interest rate, basic definition of interest rate or rates of return, and also we have talked about what determines the interest rate. So in this particular video, by the way, interest rate is also called rates of return. You can call it by this name as well. So in this particular video, we are going to look into how do we calculate the interest rate, right? And in the book, if you see, there are a total of 3 methods given: holding period return, this one, then arithmetic or mean return, and the last one is geometric mean return. So they are different, and which one to use, it depends on the situation and it depends on the context. So by the time we finish this video, it will be pretty clear where to use which method, and in exam it would mention which method you are being asked to calculate the return, so that would make it easier. So before we delve into how do we calculate, but let's first understand it's written that financial asset, 2 types of return: for invested cash and for interest, FMLs, increase or decrease of financial asset. So it is pretty much explanatory. So whenever you invest in certain financial asset, you can get return in 2 forms. Either you receive cash dividend, like when you invest in certain shares in stock market to receive dividends, or if bank gives loan is an asset for the bank, right? So they get interest on that loan. So either this form, or there will be increase or decrease in the financial asset which they have invested or which they have bought. Like if you have bought land, well, prices of the land will vary after 2 or 3 years. So it might increase or it might decrease. Depending on it, if it increase, then you are getting a positive return, right? So this is what basically the text is trying to say. And returns, you can measure over a single period, like one period called T. This is the beginning of that period. This is the end of the period. Multiple period could be like T1, T2, T3, like multiple years. So this, I'll give you with an example. So this returns that can be measured over a single period and multiple period, I'll clear it out through example. Not right now, but when we are doing this holding period return. So let's check what holding period return is. So holding period return is a return earned from holding an asset for a single specified period of time. So holding period return is pretty straightforward. What it says is, like, if you hold a financial asset, say something called ABC. So you have invested in this ABC product, could be anything, land, shares, could be anything. So when you invest and when you hold it for, say, the amount of time, and here you sell it. Here you sell it. So you hold it for a single T amount of time, and this T amount of time could be, say, it could be a day, it could be a week, it could be a month, it could be 6 months, year, 2 years, 5 years, 5.5 years, etc. So you get the point. So when you hold this ABC financial asset, hold for a single specified period of time. So the time period is specified, could be, say, 5.5 years, right? So in between, you do not sell it, you hold it, and after that T period of time, here in this case 5.5, you sell it. So here you want to calculate the return. So if I tell you by simple example, for example, if I bought this ABC at, say, $100. Okay, don't look at the formula for now. Just, you can focus on my voice and what I'm writing. So you bought this ABC at $100, and say after 5.5 years, you sell it for, say, $165 after 5.5 years. So this you consider it period 0, and this you consider it as period 1. Alright? So what is the return? My return would be, I sold it after, at how much? 165. And how much did I buy it for? $100. Divided by 100. This is the basic mathematics. So 65 by 100 will be 0.65, or you can say 65% is the rate of return, or I could say this is 65% is holding period return for holding this ABC asset, financial asset for 5.5 years. So this is our holding period return in this example. But let's assume that while we are holding this asset, so during this 5.5 years, we received the total dividend. Suppose if it is a share, if we receive a dividend of say $20 in between, so what would be the return? So I'm going to calculate it here. So return would be, I sold it for 165, right? Minus, I bought it for 100, plus I received a dividend of $20, divided by how much I bought it for. So this would be my return, 65 plus 20 by 100. This will be 85 by 100. So 0.85, or I can say it is 85% return. This is the return or interest rate, or you can call it holding period return. So holding period return, this one in this example you have seen the difference just because I have added something called dividend or interest rate. So basically you don't need to remember this formula as well. So what I have done, or what we have done here, is use this formula. So 165 here is your P1 minus how much it was bought for P0, right? When if there is a dividend, we have added the dividend, or say I'll write it as interest divided by P0. So this is exactly the formula. You don't actually need to remember the formula, right? But yeah, formula is written there. I'll just is a golf strategy. Now, what we are seeing is we have hold it for a specified T period, right? And we've used this formula and we got our holding period return. So this, we have specified a single specified period. So when there's a case of this, when single specified time period is given, it is called single period return, right? It's called single period return. This one. Let's see what multiple period return is. So you can see the formula, but I'm going to explain. You don't worry about it. So let's make an assumption. Not assumption, but let's say that you bought, I'm going to go to the rough, right? You don't need to remember this formula because ultimately we're going to use it, or we're going to derive this formula, right? So I'm going to go to the rough, and let's assume that you bought a financial asset called ABC once again. Now, in year 1, or in the first year, R1, there was you already have the data, right? So you are already have invested, and in the year 1 in the past, you saw that there was a 20% return, holding period return, or if you can simply write it as return. And you didn't sell it in the year 2, R2, the return was negative, so the value went down. This is year 2 return. And in year 3, let's call it R3, again there was a jump of 15%. So what I have written here is this 20%, this 10%, and this plus 15% each year is the holding period return for that year, that is year 1. And this minus 10% is the holding period return for year 2, right? And this positive 15% is the holding period return for year 3, right? But what if I ask you from this, so the returns are different, or it is varying over the 3 years, right? So you can say it has multiple period return. But what if I ask you, what is the holding period return for not 1 year, but you bought it at year 0, you hold it for 1 year, then you didn't sell it, you again hold it for 2 years, you again hold it for 3 years, and here after year 3 you sell it off. So for holding it for 3 years, what is my holding period return? If I ask you, how would you calculate the holding period return in this case? So this formula will use, but without using this formula, let me explain. So suppose you bought this ABC at, say, and look, I'm just giving you an example, assuming that you bought it at $100, right? You actually do not need this value. You have this interest rate. You plug in this formula, you'll get the holding period return for 3 years. But let's understand it conceptually. Alright. So you bought this financial asset ABC. Alright, year 0 at $100. So you bought it at $100. Okay. Now what happened is after 1 year, there was a 20% increase. So it must have gone to $120, right? Now, in year 2, there was a 10% decrease. Return was 10%. So from this 120, I have to minus $12 because the value went by this amount. So it is coming out to be $108, right? This is year 2. Now in the year 3, there was again an increase of 15%. The return was 15%. So this 15% is on 108. Because we're not setting in between, we keep on holding and holding and holding. So the value of that share is changing. So if you calculate, you can use your calculator. So if you use 108 multiplied by 15%, so the value is coming out to be 16.2. So if I add 108 and 16.2, it is coming out to be 124.2%. So after 3 years, you initially bought it at $100, now it is $124. So you can see that holding period return, this is the end result. I will write it as P1, this is the initial. So 124.2 minus 100, right? There is no dividend, divided by 100. So it is coming out to be 24.2 by 100 or 0.242, or I can say it as 24.2%. So this is the holding period return for holding this asset for 3 years. Okay. So basically when multiple period returns are even here, right? We have brought it down to a single period return, you can say, by simply calculating this, by simply doing our increase decrease, right? But we use this formula in the single period return. But what if in exam you cannot do this, right? So now what we'll try to do is, if R1 is how much? Just remember it. R1 is plus 20, R2 is minus 10, R3 is plus 24, and our result was 24.2%, right? So let us go back here. Our R1 was how much? Plus 20%. R2 is how much? Minus 10%. R3 is how much? Plus 15%. Let's plug it over here and use this multiple period return formula and check if our answer is 24.2 or not. Alright. So R, that is the holding period return for multiple year, plus 5. 1 plus 20%, I write it as 0.2, right? R2, I'll write it as, this is minus 10, so instead of this, it will be minus 0.01, right? This will be 15% will be 0.15. That it close minus 1. So it will be 0.2, 0.9, because this 1 minus this thing will be 0.9 and 1.15. So just multiply it. 0.12 into 0.9 into 1.15. If I multiply it, it is coming up to be 1.2420 minus 1. So it is 0.2420. 4 I can write it as 24%, right? So using this multiple return formula, we are getting 24.2%. And in our example, we also pop this, right? So if not to get confused, holding period return is when you hold a certain financial asset, right, for a specified period of time. So you use this formula, but in exam, if year 1, year 2, year 3, or even year 4, different rates holding period return for that particular year, year 1 holding period return, year 2 holding period return, year 3 holding period return is even, you can use this formula. Alright, and we'll see some example questions which are here in the book. But before that, do you want me to derive this formula, where this formula comes from? Let's do it, right? And I'll go to my rough sheet. Let's see how we can derive this formula, this particular formula. How is it being derived? We'll use this formula to derive this formula. And if you want to skip it, I have put in the timestamp where you can skip it and straight away do this question with me, right? But let's derive this formula. But if you want to check it out, please do watch this particular section of the video as well. So let's derive the formula of how we are doing it basically. So we want to derive our holding period return R is basically P1 minus P0, right? P0. Let's assume that there is no dividend or interest rate that we are P, right? So using this formula, we're going to derive this holding period return for multiple period return, right? So we're going to derive this formula 1 plus R1, 1 plus R2, 1 plus R3, minus 1. Let's derive this formula. So this, I can write it like this, right? Instead of R, I can write it as R1, A1, B1, I'm just putting 1. I can write it like this, right? And this as well, I can write it like this. R1, P0, but to multiply it here, equals to P1 minus P0, right? And P1, I'm keeping it same. This P0 goes there, so R1 P0 plus P0, I can take P0 common. 1 plus R1, I can write it like this, right? No issue, right? So this is P1. Now, similarly, using this, I can say that P2 is P1, 1 plus R2. Can I write like this? Right? Similarly, I can say that P3 is P2, 1 plus R3. Right? So, let's check this out. P3. So, P3 is, in place of P2, I'll use this. So I can write P1, 1 plus R2, and this was there, so 1 plus R3, right? Now, instead of P1, I'll write this. So P3 is equals to P0, 1 plus R1 is remaining, I'll write it 1 plus R2, 1 plus R3, right? Now, what was the formula of holding period return? It was, say, we hold it for P till P3, single specified period, right? Minus P0 by P0. Because we are holding it from the very beginning till the very end. So I've just written it P3. Or you can see P1 also, but you get the point. You are holding it for till P3. So I can write it like this. So instead of P3, I can substitute with this entire thing. So P0, 1 plus R1, 1 plus R2, 1 plus R3 minus P0 divided by P0. So holding period return, I'll just write it as R, right? So R is equal to P0, I can take it common. I'll take it out. Then 1 plus R1, 1 plus R2, 1 plus R3 minus 1. divided by V0. This, you cut it off. So finally our formula is here. So R2, 1 plus R3 minus 1. So this is the basic derivation of the formula. Hope everything is here. So we have derived using this basic formula holding period, and we hold it till P3 and we just plug in and we get our multiple period formula here. You can just write it down, or it's very easy to understand. And as written here, in this multiple period return formula, R1, R2 and R3 are these annual returns. So this is the holding period return for year 1, this is year 2, this is year 3, right? And this is the holding period return for the entire 3 years, right? And since there is a multiplication in between, compounding is taken care of. Compounding, we don't need to worry about the compounding, right? So let's do our first question. There are only 2 questions and it's pretty easy. If you have understood what I have taught in this particular segment, you're going to easily do this question. So an investor purchased how many 100 shares of stocks for this amount? This is our P0, right? At the beginning of the quarter, the investor sold all the shares. This is P1 per share. After receiving, this is the dividend or interest rate at the end of the quarter. The holding period return discloses to. So holding period return, I'll just write it as R P1 minus P0 by P0, right? What is P1? 30.50 per share. But how many shares are there? 100. So multiply by 100. Minus P0 is how much? 34.50 per share. We bought it for this much. How many shares are there? 100 shares. Divide by P0. P0 is this one only. So plus there is a interest rate or dividend of 51.5. So I'll put a bracket here, and in numerator there is a plus 51.55. So let's just calculate. This will be 3050 minus this will be 3450, right? And dividend will be this much by P0 is how much? 3450. Let's put it like that. So if you check in, it is coming out 3050 minus 3450 is coming out to be 050. Yeah, 3050 minus 3450 is coming out to be 31.55. So the entire numerator is coming out to be minus 348.45. So divided by 3450. So if I divide it by 3450, it's into 100%. So it is coming out to be 5 divided by 3450. It's coming out to be 0.10 minus 1. So you can say it is, in terms of percentage, minus 10.1%. So our answer is this one. So now let's do the second question, and it's pretty simple. So an analyst obtains the following annual rates of return for a mutual fund. So these are 2022, there was a return of 14%, 23 minus 10, 22, 24 minus 2. So these are holding period return for this particular year. So you can say R1, R2 and R3, right? The fund's holding period return over 3 years is closest to. So I just have to use the formula which we did. 1 plus R1, 1 plus R2, 1 plus R3 minus 1. By the way, if you are using the BA2 plus calculator or any other calculator which is there for the CFA, you can set it till decimal 4. So you get the exact value which I'm getting. And if you don't know how to set it, I'll comment down below how can you set it in BA2 plus calculator, right? So this 14% I can write it as 0.14, right? Minus 10% I can write it as minus 0.1. Minus 2% I can write it as minus 0.02. This you can, I hope you're not calculating this in calculator, right? Minus 2 is by 100, it will be point minus 0.0, right? So this is the value that you need to plug in. So 1 plus R1, 0.14. Here 1 plus, but it will become minus, so I'll just write minus 0.1. This will also become minus 0.102. Minus 1. This becomes 1.14. This becomes 0.9. This will become 0.98. Hit minus 1. So just use your calculator. 1.14 into 0.9 into 0.98. So it's coming out to be 1.0055 minus 1. But if your calculator is set to decimal 2, it will look something very different. So set it till 4 decimals, right? So if I do minus 1, it is 0.0055, or if you want to change into percentage, multiply by 100, so it will come out 0.55%. So B is the right answer. So we are done with the holding period return. Now we'll check out arithmetic mean. Sum it up, I would just say that when you invest in a certain financial asset, say X, and invest for, say, T period of time, and this T period of time could be for 1 day, 1 month, 1 year, or it could be sum of 3 years, right? And the very important part here is that you hold this asset for, say, 1 year, then 2 years, then 3 years. You do not sell it off in between. So you hold it for 4 years like that, and when you sell it here, so when you want to calculate the return at the end of the period when you sell, that is when you use this holding period return. Now, let's move on to this arithmetic or mean return, which is very easy to understand, and I'll also tell you what is the basic difference between these two returns or methods and when to use them. Alright. So, as you can see, arithmetic or mean return, when assets have returns for multiple holding period, it is necessary to normalize returns to common period for ease of comparison and understanding. Alright. So, my question here would be, you might be a little bit confused with this particular sentence, but it will be pretty clear when and why we are using this arithmetic or mean return. So, basically, if I ask you, if I have, say, these two stocks, stock A and stock B, and I can calculate the holding period return for stock A till 3 years, right? Some X amount will come, X percentage. Then for stock B, say if I hold it for 4 years, it will be Y% return. So, comparing X and comparing Y would be like you are comparing apple with oranges, because you are holding this stock A for 3 years, but stock B you are holding for 4 years. So, then I can say that why not calculate this till here, till 3 years, right? You can do that as well, but as an investor, what I would simply ask you or ask myself is, why not do a simple arithmetic return for this stock A and stock B so that we can compare them easily. So when you have multiple stocks, it could be like C, D, E, F, right? And you are holding it for, say, different time periods, multiple holding periods, different time period, and since they have multiple holding period, 2 years, some stock E could be like for your holding for, say, like 6 years. So you want to normalize it to a common return period. It could be, say, average return per year, so that it is very easy for you to compare all the stocks. So this is when you use arithmetic or mean return. Hope I'm pretty clear with this example. So let's calculate the average return for stock A. Average return formula is pretty simple. So return for A would be, year 1 is 10% plus 20% plus 5%. And how many years? 3 years. So just divide it by 3. So it is coming out to be 35 by 3, which is if you use your calculator, it should give you 11.66% return on an average per year. per year. Okay. Similarly for stock B, if I do, it is 8% plus 12% plus 15% plus 7 divided by 4 because we are investing it for 4 years. So again, you do the calculation, 8 plus 12 plus 15 plus 7 divided by 4. It is coming out to be 10.5% average return per year. So here you can say that average return per year of stock A is better than stock B. So this is how you use arithmetic, or how you calculate arithmetic or mean return, and you also know why and when do we use this arithmetic mean return. So this is the formula which we have used here. So Ri, you added up for till t, and t is a time period. So here it is 3, here it is 4. So it could go on like that. So this is arithmetic return. Now let's see what geometric mean return is. So geometric mean return, before I tell you what exactly is geometric mean return and how is it different from above two return, first of all, let's see the formula. Alright, I'm going to write it down. Write down the formula here. If you remember the formula for holding period return for multiple year, it was this, right? This one. So it is little similar to this one, but a bit different, and I am going to tell you why the difference is also there. So I'll just write down the formula, but before that, let me write the formula for holding period return for multiple year. Say for example 4 years. If I want it, then what I'm going to do, 1 plus R1, you already know it, 1 plus R2, 1 plus R3, 1 plus R4, right? So then you minus it by 1. So this is the formula for holding period return. What is the formula for geometric mean? So geometric mean is very much similar to this. So geometric mean for say 4 years return, 4 year, it will be something like this. So I'm going to write 1 plus R1, 1 plus R2, 1 plus R3, and then 1 plus R4. But here we put it under root by 4 because the year is 4. Then we subtract the final result by 1. So this is the formula. So the basic difference here is that I have put in this under root and 4. So if I say it is for 5 years, then it will be, I'll add 1 plus R5. Then instead of 4 here, I'll write 5. Okay. So this is a basic difference between holding period return for multiple years formula and geometric mean. And I'm going to tell you, you don't have to worry. You just be patient. I'm going to tell you why and how the difference is and what does it actually mean. Okay. So if I write the formula in general, it will look something like this. Return for geometric mean, say, it will look like something like this. Say it is for t pair, then 1 plus R1 into 1 plus R2, then you do into till 1 plus R t minus 1, that is up till t will go, right? And you put it under root of t, then minus by 1. So this is the exact formula for geometric mean. Now let's understand why we have brought in this under root here and what does it actually mean. So I'll just rub it off, alright? You don't need to remember the formula. I think if you've already grasped the concept, then you can easily tell. So what is the difference between, say, holding period return formula for multiple year versus our geometric mean? So to understand this, let's take an example. For example, if you invest in, say, stock A, okay, for say 3 years. So as per holding period return, or say like, let's put it like this. So you invest in stock A for 3 years, and let's assume that in year 1, the return that it gives is 20% positive. All right. Year 2, the return is 10%. Year 3, the return is minus 5%. So as per holding period return for multiple years, you are kind of holding this stock A for the entire 3 years, right? And you are going to sell it only after a third year. So you're holding it for 3 years. So if I calculate the holding period return, HER, let's do it. This will come out to be 1 plus 0.2, right? 1 plus 0.1. Then it will be 1 minus 0.05. Then again, at the end, minus 1. This is by using the formula, let's see. So it will come out to be 1.2, 1.1, then it will be 0.95 minus 1. So use your calculator and it should be in decimal with 4 digits. 1.2 into 1.1 into 0.95. Then minus 1. Yeah, into 100 at the end. So, holding period return is coming out to be, it is actually coming out to be 0.254, or you can say 25.4%. So, in a way, I can say that when you are investing in this stock A, and when you are holding it for the entire 3 years, you are getting a return of 25.4%. So, if you had bought this stock at say $100, then and you hold it for 3 years, now you can sell it for $125.4. This is what holding period return says. Now let's check what our geometric mean formula gives here. So for that, I'll calculate the geometric mean. So geometric mean would be this entire thing, right? 1.2, 1.1, 0.95. The only thing is that I have to do it under cube, right? And then minus 1. So 1.2 into 1.1 into 0.95. This is giving 1.254 by 3 minus 1. So this I can write it like this as well. 1.254 by 1 by 3, right? And 1 by 3 value is this, you can say it is like 0.3333, right? So in your calculator, what I want you to do is press that this one, Y, X, this button will be there. You do that. So once you do that, after that, just type 0.333 equals. So this value will come out to be 1.0783 minus 1. So if you minus 1, then your answer is 0.0783. So I can write it as 7.83%. So here you have to notice one thing. Holding period return was 25.4%, but geometric mean is giving us 7.83%. So what does it actually mean? So this 7.83 is actually your return, your annual return on average per year. So this 7.83 is average annual return of stock A. This is the average annual return, annual meaning per year return of stock A. And this 25.4 was when you hold it for entire 3 years. This is like average annual return, but this, and how is it different from our this arithmetic mean return? Here there is no, you are not factoring in compounding, but here compounding is taken care of. Compounding is taken care of. So I hope you have understood the concept. So when you invest in this stock A for 3 years, and if you hold it for 3 years, the holding period return for 3 years will give you this result. But you want to know what is the average annual return, taking into consideration the compounding effect, then you can use the geometric mean and it gives you 7.83 as the return. Oh, these things makes it pretty clear. Now let's do some question. based on geometric mean. So an analyst observes the following emergent rates of return of a hedge fund, which are presented below. So these are returns as against this year. So you are required to calculate the fund's geometric mean return over the 3-year period. So over the 3 year means given this 3 years, but what would be the geometric mean? Geometric mean means your mean itself is like average. Mean, right? Mean is your average. So average return per year is asking. So you just plug in that formula. Geometric mean is equals to 3 years. So under root 3, this 1 plus 22%, I think write it as 0.22. This I can write it as minus 0.25. This I can write it as 0.11. So 0.22. This will be minus 0.25. This will be 0.11. Then minus 1. So I can write it like this, 1.22. This will be 0.75. This will be 0.11. This entire by 3, 1. So if I calculate it, it will be 1.22 into 0.75 into 1.11, which is coming out to be 1.0157. 0.01 by 3, I can write 0.333 minus 1. So just press that. When you have this as a result, just press that x to the power, not power, yeah, x to the power y. Then press 0.333 equals. So this will come out to be 0.0052 minus 1. Minus 1. This is coming up to be 0.00, sorry, yeah, it's 0.0052. In percentage terms, you can write it as 0.52 percentage. So A is our answer. Here, you'll have to calculate arithmetic or mean return and also geometric mean for these countries, which this is also given in your book, and we'll calculate as well as we'll learn something that this one, the geometric mean is always less or equal to arithmetic mean. That is, your geometric mean will be less or at max equal to arithmetic mean. So let's see by this example if this condition holds true or not. So arithmetic mean for country D is, thus in your calculator, I would suggest add this up, minus 2.4 plus, not plus, sorry, minus 2.4, then again minus 3.1, then plus 6.2 equals divided by 3. So arithmetic mean is coming out to be, this is in percentage, right? So it's coming out to be 0.238 percentage. Similarly for country E, minus 4, then minus 3, then plus 3. The result is minus 4 divided by 3. This one is coming up minus 1.333 percentage. Third one, you have to just do 5.4, 5.2, then here minus 1 by 3, right? Just do that. 5.4 plus 5.2 minus 1 divided by 3. So this is coming out to be 3.2%. These are arithmetic mean. So now let's calculate the geometric mean for each one of them. Geometric mean would be for country D. Country D, it will be 1 minus, I can write it like this. This will be like minus 2.4 by 100. So minus 0.024, right? 0.024. I can write it like this. Second one, I can write it 1 minus 0.031 per 1 plus 0.062 minus 1. So this one is not under root, or I'm not under cube. It's still here only. So you just do the calculation. 1 minus 0.024. This is coming out to be 0.976 minus 0.031. This is coming out to be 0.969. This will be, how is this? Multiply them. 0.976 into 0.969 into 1.062. This is coming out 1.0044. Y to the power x, you press that button, then 0.333. Then minus 1. This is coming out to be 0.0015. Or in a way I can say it is 0.15%. So you can see that this geometric mean is 0.15, which is less than arithmetic mean. So well, this condition holds true, right? Let's do the second one as well. I'll leave the third preview because this is in minus. So let's see what results come for this geometric wave. So geometric mean for country E. I'll just write 1 minus 0.04, 1 minus 0.03, 1 plus 0.03. Right? It will be, let's see, of 4. When 6 and 0.97 to 1.03, right? 6 4.97 to 1.03. So this multiplying it is coming up to be this. Then 333 minus 1. 333 minus 1. So this is coming out to be minus 0.0138, or in a way I can say minus 0.138. So you might be then wondering that this is greater than this, right? You might be saying that our geometric mean, which is minus 0.138 by value, is greater than minus 1.333, which is arithmetic mean. This is geometric mean. By value it is greater. But since this is a negative sign, I would say that minus 5 is always less than minus 3, right? Or minus 5 is always less than 0. So greater the value in minus, it will be lesser. So this should be less, which is once again holding true, right? And given this leads to our conclusion that geometric mean is always less than or equal to arithmetic mean. And why is it so? I'll just give you one last example. So for understanding this, let's take an example. So supposing in scenario 1, in year 1, there was a plus 10% return. Year 2, there was a minus 10. Scenario 2. Year 1, there was a minus 10 return. Year 2, there was a plus 10 return. So in both the cases, the arithmetic mean would be plus 10 minus 10 by 2, right? It will be 0. So by arithmetic mean, we can say that average average mean return is 0. So you're not getting any return. But arithmetic mean does not give you the actual picture. Why? Because, for example, I'm not calculating geometric mean right now, but let's understand why it does not depict the real picture. So suppose you bought the stock for $100. In year 1, there was a 10% increase. 10%, right? This one. So you add 10 to it, it becomes 110. Now it decreased by 10%, so minus 11, right? So it becomes 99. So is the return actually 0? No. You have lost 1 rupee. Or you can say there is a 1% decrease in return, right? When you hold it as it. So it's not a geometric mean, but you get the idea that it's the basic point is this arithmetic mean is not depicting the real picture. So in the second scenario as well, this one, $100, you lost 10%, it becomes 90. again you gain 10% plus 9, so it becomes 99. So your asset is presently valued at 99. So you again lost $1 or 1%. So by conclusion, I can say that arithmetic mean does not give you the real picture, but geometric mean takes care of that. And let's see if we want to calculate the geometric mean, what should the value for each one of them. So for the first condition, you know how to calculate it right now. It would be 2, right? 1.1, this will be 0.9, right? Minus 1. So if I multiply it, 1.1 multiplied by 0.9, it's coming out to be this much. By 1 by 2 I can write here, or I can write something like, or it would be 0.55, right? Not 5550, sorry, yeah, minus 1. So 0.9900, press that y to the power x, now press 0.5. It is giving me 0.995, now minus 1. It's coming out to be minus 0.0050, or I can say in terms of percentage, minus 0.5%. So in the earlier example, you saw that there was a decrease in 1%, right, in return. So when you hold it for 2 years, so geometric mean tells you the loss, or in this case loss because it's a minus. So average return per year, taken into consideration the compounding. In this case as well, it will be like that only, right? This will be 0.9, 1.1. So the result will come out same. So by this, minus 0.5 is less than 0, right? Which is our arithmetic mean. So our conclusion holds true here as well. And this geometric mean gives you the real picture, taken into consideration the compounding, which arithmetic does not take care of it. So why geometric mean is always less or equal to arithmetic mean? Because of volatility. So we saw that the returns are basically volatile, right? This is volatile. And when return fluctuates, you saw in both the scenarios that gains or losses don't cancel each other symmetrically, which was cancelling in our arithmetic case. And losses hurt more than gain. So it doesn't matter that you lost in second year by same percentage or you lost in first year. Even though the value 10, it was 10 in both the cases. The gain was 10, the loss was 10. In here also, the loss was 10, the gain was 10. But even though the value was same, losses hurt more than gain helps, right? And greater the variability, greater the fluctuation, greater the, there will be. So with this video, we come to the end of the second part. So I hope you have enjoyed the video, and please do subscribe, and if you like the video, please do comment and let me know if there is anything that I can help or offer to you. Next video will be about harmonic mean, so stay tuned.